Are we there yet? Nope. Still going. Still going. Next page. Next page. There's my camera. Next page. Okay. All right. Yes. Excellent transition. All right. There we go. Top of the page here. Top of page. What would that be? 12, 13, 14, 15, 16. You know what would be better for me to do? It's to actually write what page number that is on the bottom. Hey. All right. Which I just did. This one's called the square root. Okay? It's a lot like the cubed root, but instead of being the cubed root, it's the square root. This is the one you're probably more familiar with. There is no little number in there. If there was one, they'd put a 2, but they don't make it that way. It's literally just, it's kind of like a quadratic, but kind of like the opposite, like the other way. Sure. Still 0, 0. But something interesting happens at 0, 0. If you'll notice, that graph doesn't keep going. It's just stopped. Like, there's literally no negative x's. Like, literally, if we go this way, -1, it's undefined. If we go to -2, it's undefined. Okay? What that tells me is that there's restrictions. There's things that we can't plug in for x. Like, literally, you plug in a negative value, it just breaks down. But think about it. If you're taking the square root of a negative number, it needs to be one number times itself. If you do a positive times a positive, you get positive. You get a negative times a negative, you get a positive again. There's no way to do a positive times itself or a negative times itself and end up with a negative number. So that's why we're restricted here. We still got 1, 1. That's another common one that we deal with. But then, again, this is kind of like with the cube root thing, the 0.2 something, which that 2 something would be like 2, like 1 point, I don't even know, 4, and then a billion decimal places afterwards. That doesn't make a whole lot of sense. So I'm going to skip ahead to a point that makes sense, where x is 4, and then y ends up being 2. A lot of y'all probably know this, but if you take the square root of 4, you end up with 2. Okay. Again, this is another function. It's in the calculator. Okay. When we're playing around with it, we're using it. I'm going to show you guys how to do it. This is all about just the notes here. Okay. Oh, forgot 4, 2. There you are. Okay. Domain. Here's our first one where our domain gets kind of wonky. Like we have to consider that there's actually some restrictions. There's things that x can't be because domain is the x's. It's those possible x's. So we do have a smallest x. If we're thinking left to right, the furthest left I go is 0. Okay, it's a solid dot there. I'll tell you that. It's a solid dot. So I would put the line underneath. Okay, and then x would go here. Okay, and then I'd be thinking about what my biggest x would be. But there's not one. It's an arrow. It keeps going. It keeps going. So any x that's greater than or equal to 0, or any 0 has to be less than or equal to x. So any of those x's that are bigger than 0, actually including 0, will work. Okay, the way that looks, or it would look like this: 0, comma, infinity. Okay, anything bigger than 0. Okay, range. Very similarly, it doesn't go any smaller than 0. Look, we don't cross that x-axis. It doesn't go any further than that. So what we got going on here is 0 is our lowest y again. Okay, if we look at how far low we go here, it's 0. And then at the same time, we're going to include 0 since it's a solid dot. But then it's anything bigger than that. Check it out. We got this thing going kind of sideways. It's still going up. There's that slight little like uptick. Okay, it takes a while, but it gets up there. So any y bigger than 0. Or 0 less than or equal to y. That'll work. Okay, and so then actually my range looks identical to my domain in interval notation. It would look like this. Or we'd have 0 to infinity, just like the other one. Okay. Anytime we go through the origin 0, 0, that is our friend. That is our x and y intercepts. Okay. This one, it seems like this one should have an asymptote, because you're like, oh, it stops. There's like a thing that like prevents it from moving anywhere, but it's not an asymptote. It's not like a barrier that it like gets close to. That's what an asymptote is. This is like literally it just done, stops. That's not an asymptote. Asymptotes are all about this like subtle little thing where they get kind of like close to each other. You'll see in the next one. This one doesn't have it. Okay, asymptotes are not endpoints, meaning like where they literally stop. Asymptotes are like barriers that we get close to, like closer and closer and closer and closer and closer, but never actually touch. Okay, minimum, maximum. We do have a minimum here. Okay, there is a lowest y. I think we got a lowest y. That lowest y, okay, we have a minimum. I'll circle minimum and I'll write it too. I'll say min. And that's at 0, 0 again. That's our lowest y value that we end up getting. All right, and then it doesn't go any lower than that. Okay, so that one does have a minimum. Okay, there you go. Another one of our exotics. What is that? 3 out of 5. 3 out of 5. Okay, more than halfway done. Hey.